All right, we're picking up now with the example on the bottom of the second page. It says, are these two triangles basically congruent? And they want to know, is A, so we got to see, is A congruent to D, angle A congruent to angle D, B congruent to C, C congruent to B. We're going to be careful about what we do because we got to make sure we're matching up the sides correctly. Now, if you remember, any time that we have a problem like this, we always look and mark the things that are there that they didn't mark. Well, I'm going to put 2 marks here because that is a common side. BC in one triangle is equal to CB in the other one. That's looking good, isn't it? Now we notice these are 2 right triangles, and so we know we just got through with the hypotenuse leg theorem. So let's look and see if this might be what's going on here since we see the right triangles. That's the first place to kind of think to start. Do we have 2 hypotenuses congruent? Yep, those 2. And do we have 2 sides congruent? Yep, we got them marked. It was the shared side. So because the hypotenuse AC is congruent to the hypotenuse DB, and because BC is congruent to CB, and one's a hypotenuse and one is a leg, we can say that the triangles are congruent. So we would say yes, the triangle ABC is congruent to the triangle DCB, and our reason would be hypotenuse leg. So if we were writing a proof, these 3 statements, these 2 would be, one would be given, this one would be reflexive because it's the same line, it's equal to itself, and then you've got, then you make this 3rd statement, and this would be the reason for it. Hypotenuse leg is your reason they're congruent. That would be the simple proof of that. All right, at the top of our 3rd page, this is a very important theorem. We always just call it CPCTC because, again, nobody wants to write all that stuff out in math. And it's an abbreviation for the phrase, corresponding parts of congruent triangles are congruent. It just means that if the sides match up to each other and they're congruent, if you've got 2 congruent triangles, you find the matching sides, and those 2 matching sides are also congruent. Matching angles are congruent. So that's all that means. And it's a way when they tell us that we have congruent triangles for us to say that the pieces of the triangles are congruent to each other. And so if you remember, looking right here in this box, I need to hit that. Looking in that box, it tells us we've talked about these 5 ways to show things congruent. I don't know, I'm sorry, messing this up a little bit here. We've looked at all those ways, and now that would be, we'd be working backwards if we use CPCTC, or maybe we prove things are congruent, and then since we know they're congruent, we know other pieces are congruent in a situation. So let's look at it's used in a justification and a proof after you've proven them congruent, so that you can maybe get a hold of 2 pieces that you want to say are congruent, and you're just trying to figure out how you're going to get there. So let's look at this first example. A and B are on the edge of a ravine. What is AB? Okay, so are these triangles congruent? If they are, we could say it looks like it might be equal to 18 miles. But remember when it's just got AB, that's talking about the distance between A and B. Okay, so that's how I knew that it was a number I was looking for. And since it looks like it matches up with that side, it looks like it's going to be 18 miles. But we first got to prove that it really does match up. So let's see if we can prove these triangles congruent. Okay, well, we got vertical angles that are congruent here. Let me put a dot on each of them. I'll just kind of dot with colors the things that are congruent, because I can't really get my stylus to make that fine of a mark on this. Okay, now this 10 miles is equal to this 10 miles, and then let me get a different color, orange maybe. This 15 is equal to that 15. Well, if you look, we've got side, angle, side. I'm going orange, green, purple on the right triangle, and I've got orange, green, purple on the left triangle. Those are congruent by side, angle, side. So since they're congruent, that means that the part that matches up with AB is going to be equal to AB. Well, the part that matches up with AB is this 18 miles that I had circled in red. So I now know for sure that AB is 18 miles because the 2 triangles are congruent. That's how I use this stuff, okay? Okay, let's move on to the next one down there. A landscape architect sets up the triangles shown in the figure to find the distance JK across a pond. So this is maybe some kind of architect or somebody doing some kind of surveying or laying out something might do. Find JK. Well, it looks like JK matches up with 41 feet. If these triangles are congruent by CPCTC, corresponding parts of congruent triangles are congruent, JK is going to be 41 if it matches up with MN. But before I can say that, I first got to prove the triangles are congruent. So let's see if we can do that. Well, we've got vertical angles here and here, right? So that's good. I'll use colors again. I've got this 19 matching up with this 19. And then I've got this 30 matching up with this 30. So again, it looks like blue, orange, green, yay, that's a side angle side. I could write all those segments and angles out, but just for the sake of time, I'm just going to refer to them in colors here. So these two triangles are congruent by side angle side. So since they are congruent by CPCTC, since JK and MN would be matching parts of those two congruent triangles, I know that JK is going to be equal to MN, which is, it should be equal, and that's equal to 41 feet. So JK is 41 feet. Now, you can't just plop it down there. You kind of have to explain your reasoning if it says explain your reasoning. I'm doing it verbally because I can't get my stylus to write in that small of a space. But if it were on a test and you were explaining your reasoning, you would have to say that the triangles are congruent by side angle side, therefore, by CPCTC, JK is 41 feet. You couldn't just write 41 feet and expect to get credit for that, okay, because that's not showing your reasoning. And when you write down your reasoning, you're proving your work. And that's what geometry is all about. It's not about plopping down the right answer, in case you've gotten that wrong feeling so far. Okay, so now we've got two examples at the bottom. Identify the postulate or theorem that proves the triangle's congruent. Okay, they've marked the matching side there with that one little red line. We've got two congruent angles here, 15 degrees, and we've got two congruent angles here, 150 degrees. So let's go in order. Let me try to put 2 on this bigger one. Okay, so if you think about this, what we have is angle, then straighten. If I go straight over, there's another angle, and then there's the side. I'm just looking at that lower triangle. In the upper triangle, if I start at the 150 degree angle, it would be angle, side angle. Oh, I messed up. The bottom one, let's look, the top one is angle, side angle. I messed up. I got mixed up by my markings on my diagram. If you look at the bottom triangle, if you start at the 150 degree angle, that's angle. Then immediately there's an included side, so there's the side, and then there's that little 15 degree angle, so it would be angle, side angle on both of them. I just kind of had so many markings over my diagram I couldn't see very well. Okay, so these are congruent by angle, side angle. Now, if you look over at the second one, they put 90 degrees here, which they're trying to get you to think, oh, these are right triangles. And so I'm going to mark these two little right angles. Since it's a right triangle, I'm going to check to see if the hypotenuse and leg are congruent, because if they are, it's just going to be simply HL for hypotenuse leg. Is that what we have? Yes, here are the hypotenuses, and here are the legs. So those are congruent. These two are congruent by hypotenuse leg. Always remember to add in anything on the diagram that they don't automatically write for you. Okay, let's go through these other examples really quickly. If you look at this situation here, there's something on number 3 that's not marked, and it's the shared side. I'm going to put a dot on the shared side. I would normally mark it with 3 marks, but I can't get it in that little bitty picture. I can't get that to show. Now, if you notice, all 3 sides of both of those little triangles are congruent, so that was just going to be side, side, side. If I were to prove it, if they had letters on here, I would just, on 3 different lines, list each set of matching congruent sides, and then my last statement would be that the 2 triangles are congruent by side, side, side. Okay, if we go down to, in the following, determine if the given triangles are congruent by one of the congruent congruence postulates or theorems? If so, write a congruence statement for the triangles. Okay, so if I look at this one, there's a side on both of them that match, and then there's an included angle on both of them that match. I'm dotting it with a different color. Hopefully you've noticed that. And then there's another angle here. So if you think about it, it's angle, angle, side. If I go backwards, if I start over here at the blue and I read that backwards, that's going to be angle, angle, side. That's the order the information was in. If I think it's SAA and I go, I don't remember that one, if I read it backwards, I'll go, oh, that's what they meant there. So I just got to match stuff up. So I'm going to do that up here just so I leave some room down below for the other problems. BAC, if I do it like that, remember I got to match everything up because I want to show what pieces are congruent within the triangle. I need to go EDF because that's how I can match those triangles up, those angles up inside both of those triangles. If I get too crowded here, I'll just erase some stuff and move the document up. All right, now on B, we got a shared side. I'm going to put a line on it. If you look in both triangles, there's an angle. I'll dot the two angles in blue. Then there's the blue side that's reflexive because it's the same side in both triangles. And then I'll dot in red the other ones. This is 90, and I know this one's 90 because if I have this situation, they make a line, don't they? So if this one's a right angle, this one that I'm putting the dot on over here in my bigger example here would be 180 minus 90, which will also be 90 degrees. So it would be another right angle. So if you look at this in order, I'll use green. There's an angle and then a side and then an angle, side, angle. So these are going to be congruent by angle, side, angle. And I would put, if I'm real careful about my order, I'll put triangle DFE. So I went from the top down to the right angle, DFE. It's hard to read that, but hopefully you got your volume turned up. That's what you got to do with this, okay? And then if on the other one, it would be D. Oh, goodness, it's covering it up. That would be DFG, triangle DFG. Need to have that triangle in front of it, okay? I'm going to go ahead and finish this on another video since this one's getting kind of long.